we've already started, namely analysis of 1 and 2 group data, which was the initial of this course, or at least the first part where we were taught to do statistics. So, today, ladies and gentlemen, we'll go from 2 to 3. When we have gone from 2 to 3, we can go anywhere. That's a nice thing. We are going to compare the means of 3 or more groups today. That's the topic of today's lecture. Funny enough, and you'll just have to get used to that, and by the end of this lecture, you will hopefully realize why this is so. The name of this procedure, and this is actually kind of a rather big toolbox of procedures that we initiate here to do multi-group comparisons, is funny enough called analysis of variance, abbreviation Anova, analysis of variance. Because the purpose is not analyzing the variabilities, the purpose is comparing the means. Funny name, but remember it, right? The purpose is comparing the means. The reason why I can tell you right away, the way we compare the means is actually by computing certain variabilities. There are different variabilities in play here. So it's just a name for something that we're going to learn today. Now, what I was teaching in Korea, and why the heck they wanted me to go all the way to Korea to teach them something that have been developed for decades, but it is still being further developed in different versions and in different details for different applications within, for instance, industry. Now, I've talked a lot about the pharmaceutical industry. Actually, I've worked much more with the food industry. Food industry. This is not food. But the funny thing is that the way I've been working with food industry is by working with so-called consumer and sensory type data, where you let human beings be your measurement instrument. Kind of core application in many industries. Also, for instance, in Bang & Olufsen, they use the same tools to develop image and sound quality of their products as Arla uses to develop taste and texture properties of their different type of milks and yogurts. Same techniques. So, we have worked with over many years in several research projects, among others, food industries, Arla, Bang & Olufsen, in the same industry, in the same research projects. For instance, and this is nice sometimes to be able to do what we are supposed to do at a university, that is, to do research-based teaching. Because here is a direct result of some research we've done. We have made this, it's open source, so there's no commercial interest in this. You can find some of this software on my website. I share it with you, with the world, with the industry, and it's used around the globe by other researchers and by industries around. For instance, we developed this little tool, which is a Python GUI-based thing where some R statistics going on underneath it that the user don't see. So the user would use R here without knowing it in this case. We have other R packages that we share with people where they know they use R. People in the industries become more and more adjusted and to actually use R themselves. 10, 20 years ago, no one talked about R out there in the industries. Now everyone talks about it, right? It's really changing. So for instance, here is the graphical user interface where the Bang & Olufsen TV data is in. Actually, what was done here was 12 different combinations of 3 TV sets and 4 picture stimuli. So 12 different products, 12 different groups of data, not only 2. 12 different groups of data, that's what will hit us out there, right? The world does not consist of 2 group data only. So, and we had 8 experts, panelists evaluate the image quality of these TV sets. As you could see, it was the old version of the BioVision 32, so it's quite a while ago. This picture was taken, but they're still using the methods for their new products. And hopefully they will do better and better on the bottom line also there. A lot of different attributes was measured. So people actually said, I'm not going to teach you sensory or human perceptual data evaluations now, but people sit in sometimes if it's food in taste booths and sit with the computer and they score things and it's automatically the data is taken out for data analysis to make conclusions about how we should develop our products in the company. So, as part of this, there are many other techniques available here, but as part of this, there are some analysis of variance to people. And for instance, we show some plots of this product effect. Look at that. And there is, out here it says an F value, and then we see the different attributes. So here we are actually doing some statistical testing with some F tests. We'll get to that. To tell Bang & Olufsen that these 12 products are actually different when it comes to the noise. That's one of the attributes that we use to score these pictures on the screens. So they are different with respect to the noise levels, these pictures as evaluated. This is all analysis of variance results. Let's see. I've just shared with you, just if you want to have a look, because we also shared this Bang & Olufsen data within one of our R packages, one of the recent ones we've made. I'm just going to not dig into detail now, but just let you know that if you go find this package, LMER test, one we've made, the data is there for you to play around with, as an example. There is a little R technical thing. I'm not going to dwell on that. I'm zooming in on a bit of simplifying things a little bit to make it match to our starting point here, because the data is slightly more complex than is sort of matching with our starting point, but we will get there. Next week we'll be pretty good at this. What we will learn today is something like this. One-way analysis of variance of the noise variable. And I just pointed it. Look at how easy it's done in R, and look at how it just looks exactly like a regression analysis that you were taught 2 weeks ago. Basically, the noise variable is modeled as a function of something called TV pick here, which is the coding for the 12 combinations of 3 TV sets and 4 pictures. That's a coding, that's a grouping factor for the 12 groups in this data set, right? And then I have a number of noise scores repeated for different persons and different replications. Are we up and running? Good. And then next week, I'll teach you how to also take into account this challenge there is, that it's actually some of the same people that you used repeatedly on the same scoring. So you can actually improve your analysis by taking that into account. And you should, of course. So that's what for next week. But let's get back to toy data. And then you can go play with the more realistic data. Let's take some toy data to see what is this all about now. Small example from the book, from the e-notes. We would have 4. That's the 3 groups of 4 observations that I shared with you in the beginning, right? We store that in a single vector y. We store the group's information. 1, 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, 3. And since I code it by numbers and not by letters, I should remember to let R know that please consider this as a grouping factor. There is a function in R called factor that tells R that when you use this treatment, vector in whatever you do, it will realize that it should not use the numbers 1, 2, and 3 quantitatively. It should just use it as a coding for 3 groups, a categorical variable. When you have told R that by using the factor function, it knows to treat this as a grouping thing and not quantitatively. You could jump back and forth by this if you want. You can reset it to be numeric, and then you can go back to a factor, categorical. Great, Georgi, thank you. Let's have a look. Let's have a look just before we really get started. Read in the data. I do some basic plottings here. I plot, let's see what I plot here, quite straightforwardly. One is just a dot plot showing the 12 observations explicitly like that, and the other is a box plot telling me that there seems to be some group differences here, right? Looking at this, I have some clear message. So let's not, that's the thing I'm repeating all the time. We should not forget to look at the data in an explorative way, as we started many years ago when if we were faced some data. We should continue doing that. What we can do here now is to move on and not only look at data exploratively, but try to learn from data in a formal way and make some formal decisions about what we believe in. And if we were a company like Bang & Olufsen, we can make business decisions based on the statistical analysis that we do. We don't make business decisions purely on explorative pictures of what is going on. We need some more hard numbers to support the decisions. So, statistical models